I can see that few of the participants are still joining, so I will wait for another 2-3 minutes before we start. It's going to be a very packed jam session. I will show you a few exciting things what can be done in machine learning in AWS over the cloud in SageMaker. Request you all to kindly switch on your camera for a starting so that we can see each other, and then we can switch off our camera, and then we continue with our slides and practical session demo sessions. Okay, I'm starting. So, very good evening to all of you. Myself, Neeraj Kumar. Uh, Welcome to AWS School of Data Science. Uh, I have around 20 years of experience in IT. I've been in different kind of role. Started my career as an software engineer in IBM, and then I moved over to various multinational company like Cognizant, HP, NIT, Mastech, and I work with some of the big giant in service sector, primarily in the banking and finance sectors. Work. I was responsible for managing the complete application team for the development as well as the production deployments. Right. I have been working with the cloud. Prior to this, I have uh, working with the traditional setup where we have in-house data center and all. But as the technology move, you all know that everything has moved to the cloud, and slowly we start working on the cloud. And I've been working with the clouds and AWS since last 5 years, and managing a huge team responsible for the deployment and creating the pipelines. So before we start, I just want to have a brief words from you guys. If you don't mind, can you just give me the brief, very one-liner or two-liner introduction, so that it will help me to actually understand, and accordingly I will take the sessions forward. So any one of you can start and can give the brief of yourself.
Hi, sir. Good evening. My name is Gaurav,
Hi, Gaurav.
and currently I work in Tiger Analytics as a senior analyst.
Okay.
And I look forward this session to learn more about SageMaker.
Okay.
I know the basic deployment part. Uh,
Okay.
that's it, sir. Thank you.
What about other POs? Okay, so today agenda basically I will cover this main points. Basically, what is the ML practice in industry? What are various kind of service model? What are AWS ML stacks? As a platform, how, when, and where SageMaker can fit, and how it will help data scientists to actually train your model. What are different kind of approaches that we can use in SageMaker if you want to train your model or if you want to deploy it, right? We will also see one simple end-to-end architecture, how to deploy a simple ML model. And in this approach, I will use BOIC, means that bring your container. So I am primarily going to show you how you can develop a container and you can deploy your machine learning models into a SageMaker, right? So as you so before proceeding, so I let me just give you the generic, right? What is AWS and why it is in picture and all those things. This is for the sake of everyone whoever is not even aware of cloud architecture and AWS. So let's think of that. We have a pizza as a service, right? So we can have different kind of models. We can, if we want to start our pizza delivery service, we can start up with different models, business models. Like we can start from our home, where everything belongs to me. right? When I means belongs to me is that we can have everything on premise, means at your home, starting from your cheese, topping, tomato, fire, oven, everything, whatever is required to make pizza, everything is hired by you, purchased by you, all setup is done by you, and then you prepare the pizza and deliver it to the customer, right? This is one model. This is very traditional model which used to happen in 1980s or 1990s, right? Then next model come which is called as infra as a service, right? What we use short form we say IS, right? In that's what happens. Some part of that will be owned by the owner of the pizza delivery service, and some part of it is outsourced. Like in this example, you can just think of like cheese, topping, tomato, raw material which is required is still owned by the pizza delivery owner, but some part which is depicted in blue, if you can see this diagram, like dining table, soda, electricity, gas, oven, is outsourced to some restaurant, right? So this is called as infra as a service, means infrastructure is being outsourced. You are now only providing the raw material, you are cooking it, right? But you are not bothered about the infrastructure because it's being outsourced. So such kind of setup is called as infra as a service. Now the next evolution happened, and then we started the PaaS, which is called as platform as a service. In this you can see that the green part is increasing, and then we have the blue part, right? So you just bother about pizza delivery when then you own only this part of this, the green part, and only the blue part is there with the outsourced partner. Then come a software service where the everything in to in. If you have to deliver pizza starting from your dining table, soda, everything has been outsourced. You are only bothered then as a customer, you are only bothered about the service. You go and place your order and you get the pizza. You are not bothered about like what are the raw materials, how it's been prepared, what kind of fees structure has to be. Everything has to be managed by some vendor, someone who is to whom you outsource the service, or someone who is providing the service of a pizza to you. So you just go and place your order and you get the pizza. So that is called as SaaS model. In SaaS model, which is called as software as a service, the complete software package or stack has been deployed somewhere, and just as a in the user, you go and use that software. That is called as software as a service. You are not bothered about how underlying infrastructure, how my servers are configured, how my services are is running, what kind of licenses I have to manage. Nothing. You just bother about your software or service that you want to use, right? And you just pay for it. So this kind of setup is called as service as a step, as a service, right? Software as a service. Now in the AWS parlance, if you see how this AWS mimic the same kind of service model in their cloud, right? So AWS provide you all kind of services, depends on your requirement. They can provide everything starting from the second pillar or second tower, right? Infrastructure as a service. They provide all kind of infrastructure that is required for your data center, right? So your like virtualization, servers, storage, and networking, everything will be provided by the AWS, and you only bother about the application, data, runtime, middleware, or operating system. So this kind of services or setup is also provided by AWS, which is called as infra as a service. So you can think of AWS as a service provider who follow the model of IaaS, but AWS also follow platform. So in some of the services are platform as a services where they provide the complete thing. You just think about your application which you want to run or the data. So you are bothered only, or you are the ownership of application and data is with you. Rest all is managed by the AWS. So in such kind of setup is called as platform as a service. SageMaker, specifically the session, today's session is about SageMaker. So SageMaker is a platform as a service provided by AWS to all data scientists. So you just bother about your, when I say that platform as a service as a SageMaker, then you just bother about your application and data. Rest all is managed by the SageMaker, like runtime, middleware, operating system, virtualization, server, storage, networking. Behind the scene, SageMaker manage all these things. You just have to provide your applications or data. which you want to use for building your ML models. So just keep in mind this context, like SageMaker is platform as a service within a AWS. I will show you also in the console how actually it looks like and what all ML stacks are there. And then the third and the most advanced is a service, which is software as a service. You do not even bother about your applications like CRM, right? Or any other applications which is not built by you, not managed by you, but you are just using those services or applications. So that is called as software as a service. So I'm not bothered about this software as a service. I'm today bothered about platform as a service, because the today's session is about SageMaker, which is kind of platform as a service within AWS. Hope guys, it's clear to you guys, right? The distinction between the difference between on-premise, IaaS, PaaS, or SaaS. Is that clear to you guys? I'm expecting yes or no, so that I can proceed, because as we proceed, then we will start going more deeper and deeper into this.
Yes, sir.
Okay. So the next thing is the AWS ML stack, right? So let me just go into the AWS console and I will show you what actually I'm talking about, because this session is more of about demo and practical session rather than more of theory about it, right? So this is the AWS console. So anybody who logged into the AWS, this is the first home page where you will be landed. As you can see that this is AWS management console. So all kind of management you can do using this console, this single screen. Everybody can see this screen, right?
Yes, sir.
Okay. Within this screen, you can see few things I want to just highlight. You can see, just follow my cursor or mouse, right? You can see that I am in Ohio region. But if you can see, there are various kind of region where I can go and logged in, right? As you can see that we have North Virginia, we have Ohio, California, Oregon, various, these are the regions. These are the logical divisions within the AWS cloud where you can work. When you logged in into your account, you have to log in into some region. For this session, you can see that I have logged in into Ohio. You can see this, right, in orange. I am in this region. So whatever infrastructure resources I will use from the Ohio region data center of AWS. So data center, so AWS has multiple data centers across the globe, right? So I will, in this session, when I am going to use all kind of services and resources, I am going to use which is provided by this data center within AWS cloud. Is that clear to you?
Yes, sir.
Okay. Now I'm just coming to this. If you click on all services, you can see all kind of services which are provided by the AWS, right? You can see that compute service. Within compute, there are various things like EC2, container services, customer enablement, developer tools, AWS cost management. So various kinds of all the services are logically divided into a very top level, and then they are segregated. Like all compute related services are under the compute. Similarly, for machine learning, if you see the machine learning stack, this is the machine learning, right? Within machine learning, they provide multiple services. Today we are interested about Amazon SageMaker, but apart from Amazon SageMaker, they provide various other services. As you can see that they provide something like Amazon Poly, right? This is a service which you can use to convert your text to voice. Amazon Recognition, this is basically for image processing or video processing. Amazon Tesseract is a service for extracting the text from any image or video, right? Amazon Transcribe, this is a service just opposite of the Poly. Poly mein what's happened is that you give the text and it gives the speech. Here is something different, right? Opposite. You give the speech, it gives the text out of it. Similarly, Amazon Translate, you can translate your text or voice into different languages, from Hindi to English or English to Tamil, whatever language. Multiple languages are supported by this service, right? Similarly, there are various services like Deep Lens, Deep Racer. Deep Racer is basically is for RL, for reinforcement learning, right? So there are various services that you can see that provide within the ML stack. That's what basically I mean when I say ML stack. Within the ML stack, you have various services. We are interested about Amazon SageMaker today. So let me just click into Amazon SageMaker. So this is the console of Amazon SageMaker. You can see this, right? Everybody can see this screen, right?
Yes.
Okay.
Yes, visual.
Yeah. So in Amazon SageMaker, you can see that there are various kind of menu items, starting from ground truth, notebook, processing, training, inferences, edge manager, augmented AI, and AWS marketplace. Everything has its own meaning. Like ground truth is basically for labeling, right? In machine learning parlance, right, you have to label some data. So this service, this particular menu is basically more focused about labeling. If you want to label any data sets, you can use this service within SageMaker, ground truth. Another service is a notebook, right? So notebook is basically is a service that is provided to launch your Jupyter notebook. So let me just show you how to launch any instance. So this is the screen. Once you click into notebook instances, you will come to this screen. You will have this screen. And once you click on this create notebook, right, you will get this page. Let me just give any name. Let us say I am giving demo 26. This is the name of my notebook instance. So basically what's happened behind the scene is that when I create this instance, is create a virtual machine, and in that virtual machine, it will launch a Jupyter notebook on which we will work in today's session also. Right. So let me just create this instance first. I'm just creating a IAM role. I'm making it a create new role, and I'm just keeping everything in default. I'm not making any change in these options, because I'm going to give you a example which doesn't require any customization in this, but default options will work fine. So I just say create role, and I will come back here. It's created a role and attach this role to this instance, means to this EC2 machine, which we will provision using this process, right? So it will attach this role to that EC2 machine. And once this is done, and let me just click on this create notebook instance. So I'm again back to this screen where you can see this my demo 26 instance is under process, right? The current status is pending. So it will take a few moments to actually come into service in service status or running status, right? So just give some time till it's become up and running, right? In between, let me just take you through the my slide, right? So as I have explained you, right? So AWS ML stack has various services. Some services are platform related services, like Amazon SageMaker is a platform services. AWS Deep Lens is a platform service, and there are few application services, right? Like recognition, transcribe, translate, poly. These are mainly APIs. So you will, as a developer or as a consumer, you just get the API of these services, and you can start consuming those services. Apart from that, it provides some frameworks also, all kind of frameworks, whatever you can think of, right? is provided by or supported by the AWS within ML stack. Like it supports PyTorch, TensorFlow, Keras, Gluon, CNTK, Cafe, all kind of frameworks are supported. So whatever framework you want to use to develop your model, right, is provided or supported by SageMaker. Right. So now next slide. I just want to, I don't want to take much time on this. I just want to give you the brief of the life cycle or pipeline of any ML project, right? So you have a data preparation stage, you have training and tuning stage, and then you have deployment, and then for post deployment you have to monitor all your models also, how the performance of the model is, right? So these are the basic 3 steps: data preparation, training and tuning, and deployment, and then further monitoring. Once you have deployed your model, then you start using it for the inferences. So you provide the data, real-time data, and then you get the inferences based on your model. So you, as a user, will start getting the inferences about your models, right? So that's the end point where you submit your data real time and you get the inferences. So these are the basic steps which is there in any ML pipeline. And if you go further inside into this, you can see that there are multiple, right? So there are multiple things that has to be happen in each and every verticals. So that's why it's very challenging as a data scientist who are more bothered about building the model, training the model, and or somehow related to the deployment also. Although deployment is also a part of DevOps team, right? So as a data scientist, you are basically more focused about training and tuning of your model. You are not bothered about rest all the steps required, right? Of course, as a data scientist, you are also involved in the data preparation, which is the main critical role of that. But you are not bothered about the complete end-to-end life cycle of it, right? So very specific part of it that you are interested. This is where the SageMaker, the platform like SageMaker comes into picture, which gives you a very fully managed kind of environment where you should not bother about your all other steps, like how you will bring the data, right? That is not your botheration. You have to just define few pipelines and it will bring the data within your SageMaker environment, right? You should not bother about your servers or anything, right? It's all fully managed. That's why SageMaker as a platform is called as a platform, right? All kind of services or all kind of supporting things that you require to make your complete data science or ML pipeline into in is provided in one single platform or single place, and that platform is called as SageMaker in AWS. So as a data scientist, whatever you require is provided in one single screen, that is called as SageMaker, as I have shown you, right? So let me just go back again to this, right? You can find all kind of services starting from labeling till your deployment and inferences. Everything is provided on this single screen itself, where you can do, and that's the simplification is provided by SageMaker, and that's why it's a platform. It's not a service. Service is more about providing API. Like for recognition, you will get the API. That's why it is a service. It's not a platform. But SageMaker is a platform which provides you a very consolidated or kind of environment where you can do all whatever activity you want to do as a data scientist. And that's why it's a platform. It's not a service. So that's a very important distinction between the things, right? So SageMaker is not a service, it's a platform. Okay. So now as you can see this, I have just created this instance. Now the status has changed to in service. It means that behind the scene, the SageMaker has created a virtual machine EC2 in AWS parlances, and it is up and running. It's ready to use. So I'm just clicking on Open Jupyter, right? Action. Everybody can see this, right? Okay, so I'm just clicking on Open Jupyter. So let it be continue like this. So I just want to go back to my presentation and I want to show you something very important, right? So this is very high level view of functional architecture of SageMaker, how SageMaker works, right? So if you see into this diagram, right, this complete ecosystem, right, is managed by the SageMaker. You as a data scientist is not bothered about any one of these components. All those things will be managed by SageMaker. So let's start from the left hand side, right? So you can see that there are two buckets given here, right? So these buckets are nothing, are the source through which you can provide the data to the SageMaker. SageMaker automatically pick the data from this bucket. You should not be bothered about how it will be picked and all. You have to just provide the location of this bucket. We'll see in demo session how all those things are done, right? You have to just provide the location of the buckets from where the SageMaker will put the data. And when it's put the data, it's put within the container. So right hand side, if you can see this, these are nothing, these are the images. So SageMaker automatically pull the images, instantiate the container, ingest the data, run your models or your algorithm, and create a model and put it back into another bucket. So all these things happen behind the scene. As a data scientist, you are not bothered about how images are being created or how it is being pulled, how containers are initiated. You are not bothered about that. But of course, as a data scientist, if you go to the industry, you should be aware of these terms, right? If someone asks you to give me the image, you should be able to create one image, or you should be aware of what is image, what is container. That is required, or that is expected from a data scientist in today's world, right? But the expectation is not that you should be a champion of container, or you should be champion of creating Docker file or image files, or you should be knowing in and out of infrastructure. That is not the expectation. But you should know how to use a platform or sophisticated tool like SageMaker, and how basically it works. So that's what I try to just give you a very high level view. So what SageMaker does is that it pull the training data inside the container, and it create the container using some image, which is lying in some registry, like Docker Hub is a publicly available registry, right? So in AWS we have some registry called as ECR, which is called as Elastic Container Registry. So AWS pull that image from that ECR, and it will instantiate the container, run your training job, create a model artifact or create the models. And when you actually run your, when you deploy your model, so it's create another container, and then it will pull that model artifact into that container, and it will run that model there for the inferences. And then it will create also a endpoint. Endpoint is nothing, is a serving point which is exposed to the external world or to the client applications. It can be a simple like browser, or it can be any application, web or mobile app applications. So this endpoint give you a API or endpoint, right, which you can integrate with your client applications. That application can be anything, whatever you can think of. It can be web app, it can be a mobile app, or it can be a desktop app, or it can be as simple as like Postman client, or it could be any browser enabled client application. So that you can consume this endpoint in that application, and you start interacting with your model, which is running up and running in production. You should not bother about the scalability. You should not be bothered about how the loads and traffics are managed, right? You should not be bothered about resilience. You should not be bothered about redundancy. Everything behind the scene is managed by SageMaker, and that's why SageMaker has been considered as a fully managed service. It is a PaaS, as I have shown you in the service model, right? It fall under the PaaS. Everything is managed by SageMaker. You have to only provide application and data as a data scientist in PaaS kind of service model. So that's why this is a PaaS model. It's a platform, and this is a high level functional architecture, how SageMaker works. And also you can see that there is a feedback loop, right? Once your model is up, and if you want to keep on monitoring your performance, and based on performance, if you want to enrich your data, that is also possible through this feedback loop, or using some other services of SageMaker like ground truth. Based on your experience or the changes in your real-time data, you can modify your input or training data, and you can retrain your model and enhance it in runtime, in real time, without any downtime. All those things are possible in SageMaker with some few clicks of buttons, and that's the beauty of the SageMaker, and that's why it's so popular and it's being used by many companies across industry, especially in North America and outside. It's being primarily used by data scientists for training, building, and deployment, right? So let's go back to the our SageMaker screen, right? So I have opened now. The Jupyter notebook is here, right? Everybody can see this Jupyter notebook, right?
Yes.
Okay. So in today's example, as I have shown you, I have told you, right, in my agenda, I am going to give you a demo of bring your container. Means that how you can bring your code or algorithm as a containerized thing, and you can deploy or train. You can train it and then you can deploy it to get the inferences. So I'm going to take you a very quick demo of that, how you can do that using some notebook, right? Jupyter notebook through which we can do that. So before going into that, let me just open one terminal. Everybody can see this terminal, right?
Yes.
Okay, so this is nothing. This is the EC2 machine which I have provisioned. When I have started the SageMaker, I have said, right, key instance, create notebook instance. So this is the terminal of that instance on which my Jupyter notebook is also running. It is a backend black and white screen terminal. So I have opened the terminal of that EC2 machine, and let me just do something. Type on command pvd. I just want to see where I am, what is my present working directory. I can see that I am in home EC2 user. This is my home directory, and let me do ls. And as you can see that there are already pre folders which are already being created here, right? So let me just cd to one of the folder called SageMaker. Everybody can see this, right? There is one folder called SageMaker. So let me just go inside this ls. As of now, nothing is here, right? And that's why you can also not see anything in my Jupyter notebook. Nothing is there. So for that, I am going to do the git clone of one repository, and I will get all the codes which I am going to use to deploy or training my models, right? So let me just go and get the link for that URL. Right now I am here and I just paste this command, which is git clone. I am cloning one repository, public repository, right? And it is provided by the AWS only. It is not my repository. It is provided by AWS itself. As you can see, it's doing, right? So what I will do actually in today's demo is that I will go to training. We will create a training job, and then we will create few things like we will create model, we will create endpoint configuration, we will create an endpoint, and we will also do the inferences and do the testing of using this endpoint, and then we will do one batch transformation to see how my models are working, right? So I will cover today's how to create training job, how to create model, how to create the endpoint configuration, endpoint, and batch transformation. So these 4 steps I will take you through in current demo, right? So by the time like now cloning is done, right? Let me just do the ls. I can see that this folder has been now created, right? It is being cloned. Let me just do the cd to this. As you can see that there are multiple, all kinds of folders are now created because of this cloning, right? So let me just go to advanced and then ls. as you can see that within advanced, I have various kinds of things are examples are already given, right? So I will just go to specific. My example which I am going to take for today's session is, so let me just go to that particular folder, is this one. Right, you can see that, right? Within that folder I have these 4 folders has been there, right? I have container, a folder called container, a folder name called data, and there is one Jupyter notebook or Python file which is scikit-learn bring your own container IPY. Let me just open this file. You can see that now you can see this is showing in my Jupyter notebook after cloning that, right? So let me just go to advanced, and then within advanced let me go to scikit-learn, and you can see this Jupyter, this Python script is there, right? So let me just open that. Because we guys, we have started bit late, 15 minutes, so I will take some time, right? At least 7:15 it will take. So just bear with me for some time. I will show you how to train and deploy and get the inferences on real time. After the completion of this 30 minutes, right, you will be able to see how you can train your model, how you can tune it, and how you can deploy it in the production and start consuming, right? So it will take 30 to 40 minutes to actually to go step by step and complete everything. So this is the notebook, right? Jupyter notebook. It has given the complete detail about what is there in this. You can also go through it in your time, but let me just give you the high level what I am planning to do in this. As you can see this diagram, right? So what I will do is that I will create a container, and within that container I will configure Nginx, Unicorn, and Flask app, right? So if you guys are not already aware of this, don't worry, right? So these are nothing. Nginx is nothing. It just act as a proxy server. It's a web server. It's a front end server where my request from the external world come and hit, right? This is Nginx. It acts as a reverse proxy. So all kind of load balancing, everything will be done by this Nginx server. Then we have a Unicorn. This is nothing, is a HTTP server on which my web application, the Flask application, will run. So because as you guys might be aware of that, for running any your web application, you need a web server, and specifically Flask applications, which is a Python framework to create and web applications, right? So all my training script will be wrapped inside a Flask application, and it will be deployed into this Unicorn server, which is WSDI compliant. Because for running the Flask or Python based code as a web, you need a server which is WSDI compliant. My Nginx, which is a front end server, is not WSDI compliant. That's why we need this Unicorn, where I can run my, or I can host my Flask application. This Flask application will contain all my training code script, Python script. I will show you what is inside that script. Don't worry about that. But this is what my container will contain. It will contain all these 3 servers: Nginx, Unicorn, and Flask. These all things will be put inside the container, and we will deploy it into a SageMaker, right?
So where will Amazon AWS will come here in this, in this 3?
Okay, Amazon SageMaker, basically, as I show you right in this diagram, if you go through this, the functional diagram, everybody can see this, right?
Yes.
So as I explained you a very high level, what SageMaker will do, the container which, or the image which I am create, it will pull that image. In that image I have that Nginx, Gunicon and my Flask Python applications, my training script, right? So it will, SageMaker will pull that from some registry. In in this case, SageMaker will pull this image from ECR, which is Elastic Container Registry, similar to Docker Hub. So it will pull this image. So I have to supply some input, right? For running my SageMaker, SageMaker need two input. One is need the training data and other is need the container image. So I have to provide, as a developer or as a data scientist, you have to provide a program which in the form of image, and you have to provide the data. SageMaker automatically will pull it and then it will run that container. So when I say it's running the container, means that it will run your training job, which is there as a Flask application. I will show you. Is this clear to you guys? What is the role of SageMaker here?
Yes, sir.
Okay, so just bear with me. Things will be clear. So let me just come here. I just want to show you how to create. If you want to create any container, you have to first create the image, right? And this is the code which I show you. I'm just doing the cake. You can see this. This is a Docker file. So Docker file is nothing, is a blueprint of your image. Whatever you want to put in your image, all those things will be mentioned inside the Docker file. Docker file is nothing, is a simple text file where you can mention all the steps or all kinds of raw material you require to run your programs inside a container. So using a Docker file, you create an image and then you pull that image and you create a container to run that image. So you can think of something like that. Docker file is your seed of a plant, right? And container is a full grown plant itself, right? So something like this, like Docker file is a DNA. Let me just correct it. So Docker file is a DNA which contain all the information, like in human body. All human body has a DNA, right? So it contain all basics information or intelligence that is required to run a human body, right? Your DNA cell. So similarly, Docker file is a DNA which contain all the intelligence, and image is your seed of a plant. So seed contain the DNA. So seed contain all the intelligence which is provided in the Docker file, right? So image contain your all the information which is there in the Docker file, and then using this seed or using this image, you grow a plant, and that plant is nothing, is a container. So that's the analogy. In a simple word, I can see the Docker file is a DNA, image is a seed, and container is a full grown plant. And as you know, for making your plant to grow, you have to provide resources, right? So when container run, it need resources like sunlight, air, water. So in this parlance, when container runs in this the picture, when you you create an image using a Docker file, which is a seed. When this seed become a plant, it start consuming some resource. So provide that resource, you have to create some machine, right? And that is a virtual machine where all those things happen behind the scene. The AWS will create a virtual machine, and in that virtual machine, it will run that container, or it will implant that plant into that and provide all the resources which is required, like compute resources, storage, networking. Everything will be provided by the virtual machine, which is provisioned through SageMaker. As a data scientist, you are not doing anything. You are just responsible to create your Python script and wrap it inside the Docker file, which will create the image, and you just put that image or host that image into some hub or registry. It can be a Docker hub, but in AWS, it is ECR. So you just upload that image into ECR, and through Jupyter Notebook, you just give the location of that registry. So SageMaker in runtime, it will pull that image, it will provision the EC2 machine, it will instantiate the container, and within that container, whatever the intelligence you have given in the form of Docker file, it will execute all those automatically. I hope it's now a bit clear to you guys.
Yes, sir.
Okay, so that's all those things, all those complexity is hidden, is not botheration of a data scientist, and that's why SageMaker is so powerful. It's given you the containerized way of running your or deploying your models, and ultimately it will expose your model as a web service through this endpoint. And that's why it's so simple. As a data scientist, you have to just write the Python code. All others works either will be done by DevOps engineer or by some other experts who are aware of creating image file or containers and all. But you as a data scientist should ever only bother about writing your Python script where your training jobs are. Rest all will be taken care by the SageMaker or DevOps engineers. Hope this is clear to you guys.
So is the Docker file same as API?
No. Docker, as I say, Docker file is a DNA which contains all the intelligence. As I can show you this, right? Here you can see that any Docker file start with one very simple thing, from statement. So means basically what is saying that in my DNA, I am saying that when my baby will be created, when my container will be created, it should have this kinds of intelligence. It should have Ubuntu operating system, and it should have Python. It should have Nginx server, right? It should have pip. So basically, when my baby is nothing, is just like your environment, right? So container is an environment where all the intelligence has been ingested using image, and image is created using the Docker file, which is the blueprint, which is the DNA. So as of now, in this screen, you are seeing the DNA. So I know what kind of baby I want or what kind of environment I want to run my application, right? So I am giving all those intelligence in this Docker file. Specifically, if you see, I am saying that for running my application, I need a Ubuntu operating system. So it start from a base layer, and then it will slowly build all the other layers which is required, or all the other intelligence required for my baby or my applications to run. So it's a way to package the complete dependency, complete environment. So it's create an isolated environment within your virtual machine where your application will run, and whatever dependency is required will be provided through images using this Docker file, right? So let me just proceed. So as you can see, the last is taking the Ubuntu operating system. Then in that operating system, it's installing all the requirements which you require. And then finally, if you can see this, the last line, right? I'm saying that copy decision tree to opt program. So what basically is saying that is create this folder from my local machine. In this case, this local machine, I'm talking about this EC2 instance which I have created, right? You can see, right? All these files are here. You can see this, right? If I go inside the container, CD container, right? If I do ls, you can see there is a folder called decision tree. Everybody can see this, right? Decision tree.
Yes, sir.
And then if I do the CD to this and ls, you can find that there are Nginx, there is a train, there is a serve, and there is a predictor.py. The predictor.py is your Python program. It is a Flask app. I will show you in this. If you want, I can show you here, container, decision tree. So this complete folder is being copied into the container at a specific path. As you can see it here, right? The complete decision tree folder I am copying from my local machine to a specific path within a container. So when my container will get up and running, all these things, whatever is present inside the decision tree, will be copied to this path inside the container. Getting my point?
Yes, sir.
Okay, and then I am making the working directory as opt program. So this will be my working directory of my container. Right now, let's go back and see the structure of decision tree. So decision tree as nginx server, it has predictor.py. This is the main program for which you as a data scientist will be interested. If you open this, you will see this is a simple Python program, right? And you can see that it's a importing Flask. So it is a Flask application. See here, I am creating the instance of my Flask application, flask.flask name. So everything, this complete Python script will be running as a Flask application inside the container, because I am putting everything, the complete folder decision tree itself inside the container. So it will start running this program or my application as a Flask application. And you can see inside this, there is a one program called as clf get model, right? I am pickling the model and then I am getting this model and running for the inferences or for the training. So once I train it, the SageMaker will create a model, and then at the runtime, SageMaker will pull that model. As you can see this in diagram, right? When I give this data, I give this image. After training, what is the output of any training? It's a model, right? So SageMaker will push that model into another bucket as a pickle file, as a zip file. The complete model will be uploaded to this another bucket, and then at the runtime, when you run, right, it will pull this model from here, and it will pull the supporting program which is used to run this model, right? Which will consume this model. To run that model, you need some program, right? So it will pull the program and it will provide the model, and then it will generate a endpoint which will be used for serving or for inferences, right? So let's go back to my screen, right? So I am here, right, at this phase. I just show you this. So let me just check what is the PWC. I am here, right? So let me go back here. So this is the way SageMaker works, right? Or let me just quickly take you through all the steps that we do in the SageMaker one by one, so that you can understand at least the logical sequence. Time is less, but I try to put all the concept what is there in SageMaker to actually deploy or train your model. So let me just directly go back to this step, right? So this step is nothing. Using this step, as you can see, building and registering your container. When I run this cell, so what will happen is that what SageMaker will do, or through this script you do, is that you build an image. This is the command docker build. It will create the image, and then it will push it into the registry, which is ECR, right? This part will happen once here I run this cell. So this part will be happen. My image will be ready. It will consume that docker file, it will create that image and push into a registry which is ECR after running that cell. So let me just go and run that cell first. I'm running this. Just give me a minute. You can see that output. So these two line of code is very important. It's building the image and then it's pushing the image to the registry. That's what will happen once you run this cell. The rest all are information, not that important, but this is concept wise, this is very important. So I am building image and pushing it to the registry. It will take 1 or 2 minutes to actually create the image and then push it to the registry. I will also go back to my Amazon SageMaker and I will see that whether that image has been created in that registry or not. So for that, what I will do, I will go to a service called ECR. ECR is a service, is a image registry in a AWS. So Elastic Container Registry. Let me just go there and see whether there is any image being created or not. My script is still running, so most probably it's not created that image yet. But once it's done, I can see that image here. I've already created one yesterday. As you can see, it's created on this date. See, you can see that it has created one image just now, 26 September 1836. Everybody can see this timestamp.
Yes, sir.
Okay, so it has actually, by running this cell, what has happened is that it created the image and it's pushed it into the ECR, container registry. And this is the complete explanation of what has happened. If you can see, starting step 1 of 11. So in my Docker file, I have given 11 steps. So it will use that intelligence and it will start executing all the steps which was mentioned in the Docker file, step 1 of 11. So at the end, if you can see that it will complete all the steps for creating my images. See, step 11 of 11 has been done, right? Step 10 of 11 is done, means my complete folder decision tree has been copied inside that image, and now my image has been created. It has completed 11 out of 11 steps. So my image is ready, as I have shown you also in the screen here, right? So image has been created. Okay, within this registry. Now what I will do, I will go and execute the next step. Once my image is ready, I will go and start executing the things in my SageMaker. This is just a step to get my credential. As you can see that SageMaker import get execution roles. When I have shown you, right? So when I have created the instances, I have created one role. So it will get that role. That role will provide all kind of authority to the SageMaker, whatever is required to do the complete orchestration of these steps. So role is required in AWS to perform any activity. You need some authority, and that authority is provided through some role. And that's why in the initial steps, when I was creating the instance, I have created one role. If you remember, you guys remember that, right? Hello.
Sir,
Yeah. So the same role I am getting it here. See, you can see that this is the role that this cell has run, right? So I have got that role for this session of my Jupyter Notebook instance. Once I got the role, I will start the session of SageMaker, get one specific session, and after that I upload the data, all the data which is currently in my local, right? You can see this here. If I go up, container, my data is there in my local environment. This is iris.csv. There is one CSV file. This is the training data, right? It is currently there on my local machine. This machine, in this machine, this EC2 machine, local machine on my Jupyter is running. Inside data folder, my all training data is there. So what I am doing is there in this cell is that I am taking this data and pushing it into a S3 bucket. Which bucket? I am putting into this bucket. I have already done with this image part. Now I am creating another input, which is the data. I have provided the program application. Now I provide the data. So I will have both the ingredients, my training script as well as my data. So let me just upload this. It's being uploaded to a S3 bucket. I can show you here. If you go to the service called S3 bucket, let me just go to S3 and show you where it is being uploaded in AWS. So all these things is happening through SageMaker. You are not doing as a data scientist. If you see at the net, you are just running the Jupyter Notebook. Rest all are being done by the SageMaker. That's why it's a fully managed. You are not bothering about that. You are just providing the application and data as in a PaaS business model. as I explained you, right? You have to provide only program, application, and data. So program we have already provided in the form of a container. Data I have already now uploaded in the S3 bucket. As you can see that there is a S3 bucket. This is the S3 bucket, right? That it has created. Inside that, it has created this folder. In this folder, it has uploaded this. You can see the timestamp also, right? It's a 26 September 1840. So just now it has uploaded that data from my local EC2 machine on which my Jupyter node is working to S3 bucket in AWS cloud. So these two parts is now done. I have provided the input data and I have provided the application. Now what is next? I have to run this container, right? Yes or no?
Yes, sir.
Okay, so I will run this container now in Jupyter Notebook. So let me just go there. So data is uploaded. Now this is the steps where you can run. So you can see normal, any training you have a fit, right? So I will fit my training script or training model into this data. And you can see that what I am doing is that I am in this API, right? I am just providing the image. Where is my image one input? I am providing the role, what kind of role that is need to actually perform that or do the orchestration, bringing my application and data. So it needs some authority. So I am providing that role. I am providing that image, and I am also saying that what kind of machine I want to run my training job, right? So that's the flexibility of SageMaker. You can provide whatever kind of machine you want or infrastructure you want, you can specify. As of now, I am using ML C4 2x large. If you want GPU, you want TPU, all kind of virtual machines are available in cloud, within AWS. So you can mention, depends on your workload, you can provide the size of your machine. And then I am saying that once my training, my fit is run, right? Provide this output to this S3 bucket. This is nothing, this. I'm now talking about this bucket. When my training is over, when my fit is over, provide the output, the model artifact into this bucket. That is this step, which I am providing it here in this. Everybody are getting my point? So I started my training job. So you can see that my training job has started. So as a data scientist, if you see what you have done, you have just created a Python script and created a container where you are running your Python script as a Flask. Why you are running as a Flask? Because you want to deploy as a web application, so that any web client like browser, Postman, or any web application or mobile application can consume your model. That's why it's wrapped inside a Flask. And we kept everything in a container, which is running within a container. My Flask application, my script, my training model is running inside a container. And
So,
all
sir,
those, yeah.
sorry to interrupt. That predictor.py, that was our model. Then it automatically took that CSV file, which is our training data. And then now we are running that, we are testing a data, like predicting it in this particular step, is it?
Yeah. It's a training job is happening now.
Okay, training is happening now. It has already taken the CSV file.
Yes. So for doing your training, you need two things, right? You need a training program, a Python script, and you need a training data. So both the things we have provided inside container through SageMaker. SageMaker does the orchestration of bringing my data and bringing my program and running it as a container behind the scene, and
But
that's what is happening.
How would it know which model to pick up? Is it regression problem?
That's why I say, yeah, your question is very valid. I have given this image, right?
Yes.
And in this image, what I have provided, if you see the Docker file up, I provided this, right? Decision tree folder.
Decision trees, yes. So it is using decision trees.
Yeah, it is using the decision tree folder. Within decision tree folder, there is a predictor.py file. This file is there, right?
Yes.
So that's why through that image, when my container is running, my predictor.py is already there in that container. Okay. And when I am running this script or this cell, so by this mentioning this image here, if you see the image, I am providing this image name, right?
Right.
And this image is coming from where? It's coming from a ECR. If you can see that ECR is written, right? It is coming from this container registry, which I have shown you.
Right.
Right. So it's pulled that image from that registry and put it inside the container, and it's also pulled the training data, and it's now running my training job.
Okay. So now it is training the model. No.
Yeah, it's all,
the
all
data.
about training.
Okay. Okay, sir.
So you can see that training image. SageMaker is downloading the image from ECR, downloading the input data, it's downloading the data from S3 bucket. If you can see the steps, it's saying that it's preparing a instance for training. So lot of things SageMaker is doing, means that it's creating a virtual machine, because for running a container you need the resources, right? This container is like a tree, so it needs sunlight, air, water, right? So those resources will be provided by some machine.
Okay.
And that machine is nothing, is a virtual machine that SageMaker provision you behind the scene, and in that virtual machine it is running that container.
Okay. Right. So that is your Amazon AWS service. SageMaker is providing all of this.
Yes. So SageMaker provide you all the integrated environment now, right?
Right.
And as a data scientist, you are only bothered about writing predictor.py, nothing else.
Right.
And that's the beauty of SageMaker. You just stick to your domain. As a data scientist, your domain is to write a Python script or training job script.
Right.
Rest all managed by the SageMaker. And another thing is that it's a fully managed and it's a fully scalable. If you want to have a very big machine, you can have a big machine. That also you can control.
Right. So we can purchase, and it will only be charged as
it will charge only for that time, till the time my training job is running. See, it's charged me, it's very clearly saying billable session is only 47 seconds.
47 seconds, right.
Right. So it's billed me only for 47 seconds here.
Okay.
And that's the beauty, right? Is the cloud. Pay as you go. You pay only for that when you use. Otherwise, think of a scenario when I started my career. For running this simple job, I have to purchase a big server.
Correct.
Right. And that's cost me around 10 lakhs. Now I'm doing it in free, because it's a free tier account. No cost, zero cost. In $0 I am running this. So that's the cost saving the AWS provide. And the scalability.
For our training, while doing this course, we can use this account and it won't charge us anything.
If it is a free account, if I have opened a free account, then up to certain quota is free.
When you say certain quota, what does that mean? So certain megabytes or gigabytes, or is it like that?
No. So let's understand that. So the thing is that the way the AWS do the billing or charging is designed something like that. Think of that you have a complete tower with you, right? AWS is a tower.
Right.
Within that tower, you have various flats of different size: 2 BHK, 1 BHK, 3 BHK, 4 BHK, mansion, duplex,
so it has
everything.
Small systems, like you configure 4 GB RAM, this processor and all of that. You select that, and after that, it will bill you.
Yeah, it's like that only, right? So because see, I want in that tower, I want a extra large flat.
Okay.
Right? Because depends on my workload. I want a 4 BHK flat because my family size is big. Right. I'm staying with my parents, so I need a extra large flat.
Right.
So that's why I ask for this, and I pay for this only for 47 seconds, not for 1 month.
Okay. So that ml.c4.cx large, that is a configuration.
That is a configuration of a machine, virtual machine.
Machine. Okay.
Yeah, virtual machine that it will provision.
Got it. So one more thing, you said it is free. Then how is it free?
No. So what I'm trying to say is that as a promotion or as a motivation for a learner, what SageMaker or AWS provided is that there are certain kind of flats, like a single 1 BHK flats, that is free for you.
Okay.
Understood. But I will not provide you GPU and TPU free.
Okay.
And in that also he's saying that I will provide you that 1 BHK only for 3 months.
Okay.
I will not provide you for throughout the life, that you come and stay there for
Like
your life,
trial. Understood. Okay.
right? So that's the definition of a free tire.
Okay.
Getting my point?
Yes, sir. Yes, sir.
Okay,
Thank
so
you.
now my training is over. If we now go, I go back to my SageMaker service or platform. Here I am just opening SageMaker. I will show you something what has happened so far within the SageMaker. So if you come here in the training part, it will show you something called training job. So this training job, you can see 26 September, right? It is UTC, that's why it's showing 1313, right? So it has run this training job. And if you open this, you will see everything about the whatever has happened in this training job. One important thing I want to show is that the output. You can see the output data is saying that this is the path where after running this training job, my output or my model will be stored.
Okay.
Okay, so if I go to again my S3 bucket now, because my training job is over now, my model should have been created and pushed to that S3 bucket in this diagram, right? In this bucket, it should have been pushed by now, right? So let's just go and verify that. So this is my S3 screen, and I will go to this bucket, and I will go to output, and you can see that there is something like this one, right? 26 13 13. If I click this, within that there is an output folder, and you can see model.tar.gz, and you can see the timestamp, right? It's 1846.
Okay.
So it has created my model and pushed into this bucket.
Okay.
After completion of my training job. So that has happened so far. So far we have done with this part, training part, right? The lower part of this picture.
Right.
And we have reached up to this bucket where my model artifact is there. My tar file is there, which contain my model.
So in this bucket, we basically have our train model.
Yes, you have your train model there.
Okay.
Now the next step is that you have to deploy this, and then you start serving your model as an endpoint. Yes or no?
Right. So here we'll do our, generalized. I mean.
Yeah. So you can see this now, the hosting your model.
Okay.
So deploy your model is as simple as just running this cell. It will deploy it. I just run this, right? So now it's deploying it. It's creating this. It's creating another virtual machine. It's bringing the another my serving program. Is bringing my model, and then it's starting my container within that virtual machine to start my production server, virtual server, where my model will be keep on running and ready to listen my request. Okay, so it will do multiple things behind the scene. It will bring my production grade application. It will bring my model. It will run a container, and this time my container will remain up. It will not go down like my training.
Okay.
Because it continuously has to serve the request when it's come in production real time.
Right.
So what it will do, that it will keep this container up and running, and it will also create an endpoint. So behind the things, many things. I don't have a time. I cannot explain. So it create load balancer. It create all kinds of ELB, elastic load balancers, and it create various kind of replication of your models in different zones. So that's why it provide the availability and redundancy. So it's not only hosting your now serving or hosting your production model in one location. It is making it available in multiple. Although I am running my in as of now, I am running in which region? If you see this one, I am currently in Ohio. If I go back to any service, let us say, if I go back to Amazon SageMaker itself. Right, I am in Ohio region, right? So when it deployed this model, it is not only deploying in Ohio data center, it is also deploying in multiple availability zone, so that if even if my one of these virtual machine goes down, I have other servers in other location which is keep on running. and this endpoint has an inbuilt capability to transfer my traffic from here to here. So all those things have happened behind the scene of load balancing, or or diverting your traffic from one availability zone to other. All those things are done automatically behind the scene, and that's why when you are deploying in AWS with this kind of configuration, which I have shown you, where you have Unicorn, where you have Nginx, and you have Flash application, it's a production ready. It is ready to now serve billions of customers. Try to understand what kind of models you are deploying now. You are not bothered about scale now. Everything will be managed by SageMaker, and it's just give you as simple as a API, as an endpoint, which you can integrate with your any application, and it's ready to serve any kind of traffic.
Okay. So,
Okay,
can we say that, after S3 bucket, it is integrating our model with the front end app? Is it like that?
No. So it's just giving you an API.
Okay. This is
And
giving
that-
us the API of the trained model.
It's giving this one. It's giving you. It will give you endpoint. Endpoint is nothing. Is a API. I will show you. When I
Okay.
train now, I will show. When I deploy is over, I will show you. When I create the
Okay.
endpoint, I will show you. It will
Awesome.
give you a URL,
Okay.
and that URL you can put it any applications wherever you want to integrate, whichever application you want to integrate.
Okay. Okay. So the application creation is separate through Flask or through anything.
Yes.
Okay. Okay. Understood.
Okay. So my this one deployment is still happening. It takes some time. Just give me a minute. So multiple things are happening behind the scene. It looks like only 2 line of code, right? If you see it from the beginning, how many line of code you have written? You have written few basic commands,
Yes, very few. Yes.
right? 6 to 7 line of code you have written, and you are deploying your model production ready to consume any kind of traffic, any kind of scale. Think of the power of SageMaker, and the
Right.
kind of beauties provide everything in one screen.
Nice.
Right? It's just taking some time, because for deploying it has to provision that machine, right? ML
Yes,
M4 X large. So it's taking some time to provision that machine, and then deploying your model, bringing your container up, and all those things, bringing the load balancer, everything, and replicating into different availability zone. It's taking time. It takes hardly 5 minutes. It will over. Almost it's over now, I believe.
Okay.
So once it is done, what we will do is that we will create a test data, simple test data, to test that whether I am getting the inferences or not, right? Because it's a iris data, so I will provide some data, and it should give me some output saying that whether it's a sitosa or whatever flower, right? So just give me a minute. Once this training is over, I will show you that. We are almost done. We are in inferences. If you can see that, it has already created that model, right? 26. It has already created a endpoint configuration 26, 13, 23, and it is in the way to create my endpoint in service. Now my endpoint, see, if everybody can see this, right?
Yes, sir.
So my endpoint is now ready in service. If I go inside this, I will show you what basically I was saying that, right? See, this is the URL. This is endpoint URL.
Okay.
And now you can copy this. You can use it in the Postman for testing. You can use this URL in your mobile app. You can use this URL in your web application. You can use this in your desktop application, wherever you want.
Okay.
Getting my point?
We'll have to integrate this to a front end.
Yeah. In the some front end you have to, right?
Correct.
Or if you don't integrate in any front end, then you can integrate with your back end applications, right?
Backend as in, I mean, SQL or.
No. I'm saying that let us say you are running a application whose job is to just the business requirement is that I will give some input and I will get my classification output
Right.
in your application. That is the need.
Correct.
So that is your business application. You are developing a business application.
Right.
In that business application, at some place you will provide some input and you are expecting the classification output.
Correct.
In that program and in that place you will paste this link.
Okay.
And you will provide the input data, the inference data, real-time data as a JSON, as a text file, whatever you want.
Okay.
So, okay, so this is nothing, this is a REST API. You integrate this REST API into your application.
Okay.
Okay, and in REST API, you can provide your input as a JSON data.
Okay.
It will come to your container inside the SageMaker. It will provide that data. Your training job or whatever model will see that input data, and then basis that it will give you back the inferences, and that you will find it in your application, and then you can proceed with your next step of your business application.
Okay.
Right? So that's the way it's happened. Now it is done. Right? So now I am creating just mimicking. I am just creating a dummy data, which I will use to see the instant, right? Inference. I run this 3 cell. This is just simple Python code, and now I am calling this function predictor.predict, and I am providing this test data as an input. Right? Same thing you will do in your client application. When I run this, what will happen is that it will give me some prediction. See, it's giving me the prediction now.
Yes.
Right?
So don't we check the accuracy and stuff like that? Yeah.
Yeah, you can see the accuracy also in your logs of your model logs, which you can see very much in the backend in SageMaker. I don't have a time, but I can show you. You can see each and everything what is happening.
Okay.
Okay. So this is what is happens. This test data is being given to this model and is giving it back your decisions.
Right.
And I can show you if I go back to data. Bring your model. I go to data. Right. If I open this, you see, right? This is the test data, but you can see that the first column is the
Setosa.
It's a training data. So I'm providing the label. But if you see in my script, right, when I created my test data, I have removed that. I have dropped 0 column. I have dropped the label. Getting my point?
Yes, sir.
And then when I push it, I get this. Now the time, actually I want to show you something, but time doesn't permit. So I'm just deleting this endpoint, right? Because it's chargeable. So what I'm trying to say is that this is what has happened. Let me just summarize everything what has happened so that you guys can understand. You can see this model, right? This diagram.
So if you can zoom in, because it's not clear what's written.
Let me just do. It's okay.
It's not visible really.
It's now okay.
Yeah. That's much better.
Okay. So now if you can see this is the high level architecture what we have done in last 45 minutes. The innermost box contain your Flask application, which is consist of Nginx, Unicorn, and your Flask application, which is your predictor.py. Right. So this is your complete decision tree folder. And you can see this is running inside the container. You can see this one container, right?
Yes.
And this container is hosted inside this box, which is a virtual machine provisioned by SageMaker. Getting my point?
Yes.
Now, so from the starting, what we have done, we have created a Docker file. If you see this, my purple color, right?
Yes.
Using this Docker file, I have created the image.
Yes.
That image I have pushed it to the ECR.
Right.
right? Elastic Container Registry, like Docker Hub. And when I start my training, it has pushed this image from this Docker image and started this container inside this virtual machine in the training phase,
Right.
right? And in the deployment phase, what is happened? It has pushed again the same image, right? Or different image if you have different version of your production code, and then start running that model inside the container, and then created a SageMaker endpoint. And this endpoint is actually hooked to the Lambda function API gateway, and through which it goes to the other applications. So whenever you want to integrate any client application like mobile app, right, then you have to talk with this SageMaker endpoint using these two more components. As of now, I have shown you within the Jupyter notebook, right? But if you want to consume this API, REST API, you have to create two more components or two more services of AWS. One is called Lambda function, which is a serverless component, and one is the API gateway. These are very simple things. Within the few click of button, you can create an API gateway and Lambda that you can attach with the SageMaker endpoint. And now once you create your API gateway, then you can interact with the external world directly. Getting my point?
Yes.
Right? So these two components I have not shown you in this today's training session or demo session, but these are, take my word, this is just a matter of 10 minutes. Click of some button, you can create API gateway, a Lambda function, again a Python code which can talk to this API, where you can hook this API, the endpoint URL, and then at the end the API gateway will expose you an REST API that you finally integrate with your whatever application you want. But ultimately, this API gateway talks to you, this SageMaker endpoint only. Getting my point? So with this, I just want to come to conclusion that anyone has any doubt or any question can ask me now.
So one thing inside that container, you said we also have Flask, but
Yes.
Flask isn't it used for deploying, our model to the web server?
No, 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 no. See, Flask is Flask application. So Flask is a very lightweight framework, right? It is not a full-blown web application. Means that it's not capable to manage multiple threads. It's not able to manage your loads, everything. And that's why when we have done this, we have provisioned few things, something like I show you here, right? We have put a web server, a dedicated web server, Nginx,
Yes.
for facing the client request. Because if you directly start hitting client request to the Flask application, it's a single thread application. Flask
Okay.
application are always single thread
Right. So it won't be able to handle that much.
load, right? And that's why
Yeah.
I have put it behind a professional web server, which is Nginx.
Okay.
And Flask is your web application, so you have to host your web application on some server, right? And that server has to be a WSDI compliant, and that's why I have used Unicorn.
Okay. But what if again, even if we get multiple requests from, a lot of users are actually, trying to access our app or whatever. So this Nginx, you said it is a virtual server. It is capable because maybe it has multiple threads.
Yeah.
But
So
how does that work? Because even that is requesting the information from the Flask itself, right?
I will show you how that's happened. Basically, what's happened is this. I will show. Let me show you one. Let me just start paint. Everybody can see this screen, no?
Yes, sir.
Okay. So what has happened? Let us say this is your endpoint, right? This is your endpoint, which is generated by SageMaker. Okay.
Okay. Yes.
Behind the endpoint, what SageMaker does is that it create a load balancer.
Okay.
It is called as LB. So basically, it is the ALB, application load balancer, right?
Okay. Yeah.
And what this load balancer is does, because as I told you, right, to SageMaker replicate your model into multiple availability zone, right? So what when you deploy your model, what it does is that is create your model in one availability zone. Let us say AB1. So availability zone are nothing, are the data centers, different data centers within a region,
Right.
right? So it's create a various replica of your model and deploy. This is your model, right? Let us say this is your model.
Okay. Yeah.
When SageMaker create, when you say deploy, right? So what
Mhm.
SageMaker will do that SageMaker create the replica of this model and is deploy into different data centers,
Right.
right? And what another thing that ELB, when this traffic comes, HTTP request comes, right?
Hmm.
HTTP request comes to you.
Right.
So it goes to the ALB, right?
Okay.
And then ALB depends on the load. It will divert it to different servers,
Okay. Right.
right? And now in this servers, this within this ability zone where your model is there is a virtual machine, right?
Right.
And within
Understood.
that virtual machine your container is running,
Correct.
right? And in that container you have another layer of Nginx, Unicorn and Flask.
Okay.
Okay, so that whenever any HTTP request comes, it directly doesn't go to the Flask, it goes to the your
The load balancer. Yes.
Nginx server. From Nginx to Unicorn where your Flask application is hosted,
Okay. Yeah.
right? So all these things, see, these are the very simplification picture of SageMaker I'm showing you.
Yes, sir.
So as a data scientist in net, if you see, what you have to bother about is a very small part of that is py file,
Right.
right? Rest all scalability, redundancy, resilience, availability, traffic, load, server,
Everything
everything
will
is
be
managed by SageMaker.
okay.
And that's why it's a platform, it's not a service,
Right.
right? So any other question, guys?
That's pretty much it.
So SageMaker, that's why SageMaker is very powerful. And I have shown you a very small part, tip of iceberg, right? But SageMaker is so powerful is that, you take my word, 80% of current workload, ML workloads are running in SageMaker in industry nowadays. There are various other concepts because SageMaker, I can show you, right? Another service, one important service, EKS. It is a Kubernetes service, right? So what basically happens, SageMaker actually integrated with the Kubernetes. Kubernetes is nothing, is a container orchestration platform. It's an open platform, right?
Okay.
So AWS provide this Kubernetes. So all your containers now can be managed in Kubernetes. And Kubernetes is supported by which company? Google. Google has given this open source. The Google data centers or Google millions of containers are running or microservices are running. All they are running under the Kubernetes cluster. So you can think of, like, if you can integrate your SageMaker models with the Kubernetes, and on the top of that, if you create your ML ops pipeline using some tools like Kubeflow or MLflow or AutoML, your complete pipeline of what I'm saying, that this complete picture, right?
Mm-hmm.
I'm saying this complete picture. This complete picture is
Okay.
called as the ML pipeline, right? So you can
Right.
create the complete ML ops, machine learning operation, DevOps pipeline in AWS, which is supported by some special components which are excellent in doing their jobs. Like for maintaining container is a Kubernetes, for training your jobs, tuning your jobs, for making the deployment is a SageMaker, right?
Okay.
For maintaining your data, there is a S3 bucket, for maintaining or all your storage, there is a EC2 and various kind of infrastructure, right? So as a SageMaker, what SageMaker is doing is that is provide you a platform. On the same platform, you can integrate with your EKS Kubernetes service. You can integrate with your S3. You can integrate with your Lambda. You can integrate with your API gateway. You can integrate with your all whatever services you can think of that AWS provides. Everything can be easily integrated, is already integrated with the SageMaker. You have to just write few lines of APIs. What I mean to say API is that these codes.
Just a model building.
You as a data scientist, you have to create a py file, right? Predictor.py,
Right.
just in this example. Apart
The
from
model
that,
building, basically.
apart from that, you have to call these APIs for integrations.
Right.
So think of, you can build complete your applications, right, in pipeline using few line of code, and at the same time you get all kind of scalability and everything in AWS, which is very much required for ML, because these are very toy example, right?
Correct.
But think of that in a Citibank or a ABN bank, where the billions of records are get processed, and you have to give the inferences in the real time, in a millisecond, in their client applications. For that kind of workload, you need this kind of infrastructure or this kinds of ecosystem, right? Otherwise, there is no point of developing just model. Your model is of no use if it doesn't find a suitable platform where you can easily manage that.
Right.
Right. So that's SageMaker provides, and it provides everything on the single screen. This screen provides you everything, whatever as a data scientist you need. This screen provide everything.
Okay. Right. So it basically, create models plus inferences is SageMaker, and that
Yes.
Kubernetes was end to end, like right from cleaning SageMaker till deploying it and making the application also.
Kubernetes is your container management, right? So what basically Kubernetes does is that you can give a declarative statement in the form of ML or JSON to Kubernetes, and you can say that what will happen if my traffic increase? Will my container get replicated? How much should be minimum? How should be maximum? If any of my container dies, then what should do? So everything
so is that
has
like
been given.
your Hadoop, sir?
No.
Hadoop.
Kubernetes Hadoop is your big data thing.
Big data, because that also does. I mean, it has something like that.
So AWS provide you Hadoop also. There is a service called EMR.
Okay.
Right. This is. I'll just show you what is EMR. Welcome to Amazon Elastic MapReduce.
MapReducer, right?
Right. So this is the Hadoop functionality that has been built. So underlying technology is Hadoop technology only, but it has been exposed in AWS EMR.
Okay, Elastic MapReduce. Okay.
Right. So it's a Elastic MapReduce. So all kind of data related things you can do in EMR. All kind of container related thing you can do in EKS. All kind of machine learning thing you can do in SageMaker.
SageMaker. Okay.
Right. So it's a complete ecosystem. So take my word. So kind of services that AWS provide. I just show you this console home, right? Just take this, see this kind of services. Now you can get the feeling of that. Right. So anything, whatever you can think of or you can dream on this planet to build, everything can be built on AWS cloud with click of buttons. But just bear, because it's provided you so much of comfort. So you have to give so much of respect also, because it's a very sophisticated environment. A single click of button can do a boom for you, or it can create a bust for you also.
Right.
Right. So it is something like you want to enjoy a Mercedes Benz, but you can afford only 800. Then there is no point of giving, because then you will not able to actually maintain or give respect. Correct. Even if you start driving Mercedes, right? So you have to have that kind of skill set, that kind of training, and that kind of sophistication in your thinking and in your architecture building. Then only you can come to this kind of Mercedes Benz platform.
Correct.
right?
So one thing
But yeah,
you said about these Amazon Poly recognition. So recognition was for image recognition, right?
right.
So that image recognition, I mean, how will that work? Like, I mean, does that give you an API ready-made,
Ready-made
model?
API.
So that
Yes.
is giving you a model. You just have to feed data, is it?
Yeah. So what basically all those services, let us say, these services like Poly, right?
Uh-huh.
So Poly is nothing, is a API service,
Text to speech. One that was right.
right?
Uh-huh.
Lifelike speech, not only speech,
Okay.
it's lifelike speech.
Okay.
So and it's using deep learning technology behind the scene,
Okay.
right? So what is basically give is just give you something called as API.
Okay.
In that API, if you feed your text in the form of a JSON data,
Okay.
it will return you speech against that.
Okay. Okay.
So you do not need to like it is a SaaS model,
So okay, software as a service. It is
right?
basically ready-made software.
Yeah, ready-made software. You have to just use those services
Okay. So
and
when you said text file, sorry,
uh,
so does that mean whatever we want the speech, like,
hmm,
let's say that file has a paragraph and we want a
hmm,
speech of that paragraph. So that is what
hmm.
we have to give it to Polly and Polly will just create a speech. Is that right?
Right. And
Okay.
it support all kind of audio formats and all kind of language.
All kind of languages.
Yes.
Okay.
Even I believe that recently they have started Hindi also and Tamil also, Bengali also.
Okay. So, and is there a translate also inside it? Like if I give a Hindi text in it,
Hmm.
can it translate into English? Is
No,
that
so you have to club it with the translate first.
with a different API or different model?
Yeah,
Oh,
so that is again
okay.
API service. Translate, right? I have shown you right in the beginning.
Okay.
There are service called as translate also. See, if you see translate,
Okay. Yeah.
right? So translate is there, transcribe is there, transcript is there. So see, you think of what is happening is basically, if you think as a human body, right? So
Uh-huh.
human body, how human body works, it works on the basis of senses. What kind of senses you have? You have senses for sound, you have senses for vision, you have senses for speech, right?
Right.
So take this as a like sensory,
Right.
right? And if you want to create a body which is capable to perform some function, you attach this sensory to that body,
Right.
and then you can create whatever you want to do with that body, right? He behave like a robot.
Okay. So our job is just limited to integrating, this to something because these are all
Yeah,
ready-made models. We
ready-made
don't have
models.
anything to do anything. I mean, we just have
No.
to integrate with the front end or whatever, and
Yeah.
you have your live thing. This is okay.
Yeah. So these are service, right? Pay as you go. For each
Okay.
invocation is a very minimum charge.
Right.
If I go here, just let me show, because you asked, is see Amazon Poly pricing.
Okay. Yeah.
If you see the pricing, those are very minimal pricing. You can see the free tier pricing, right? See, 10,000 request for 10,000 character per request, text length 1 million characters, speech duration 23 hours 8 minutes. Cost is what?
$4.
$4,
Okay. For one day,
right?
approximately one day.
No. So it is for, see, it is for 1 million character,
Right.
or
Okay. Yeah.
speech duration of, like, if you want to speak for complete day, you pay $4.
Okay. So it is limited to 1 million characters. If it exceeds
No.
1 million,
So this is just a traffic rate.
okay.
This is a tariff, something like electricity tariff, right?
Right.
You cannot say that my tariff rate is 1 kilowatt is for 100 rupees, so I have bandwidth of only 1 kilowatt. Whatever you want to consume million watt, you have to pay according to that traffic
Okay.
tariff, right? It's something like that.
Understood.
See, देखो free tire में, if you see the pricing of free tire, millions of character per month is free. and that is free for first 12 months. So up to 12 months, every month you can have million of character get converted into voice free of charge.
Okay. So can you give an example, like how much characters, like, for an example, like in one day, if we give it like
No, so it's very simple.
100
See,
pages.
saying that, right? Free tier means million of characters per month. So in a
Means 10
month,
lakhs. Mhm.
in a month, you 10 lakhs character you can feed to the poly, and poly can give you the voice for that, free of
Okay, and
cost.
that's for free.
Right?
Okay.
That is monthly quota. But same thing you can do up to 12 months, means 12 million character is free to you.
Okay.
But
Understood.
for 1 month, it's a 1 million character.
Okay.
So 12 million character is like literature, right? The
Correct.
complete book,
Yeah. Nice.
right? So I hope that I cover some of your doubts about SageMaker.
Yes, sir. Very informative session. Thank you.
Okay, so we are also going to launch the full course on this. You guys can interested can come to Aegis, can join. It's going to be a kind 30 days,
30 days course.
30 hours course,
Okay.
but it will be on weekend based.
Okay.
Okay. So for working professional also we provide services.